Hey guys, Mr. Rizutko here, coming to you with the first of what will hopefully be many review videos over the study guides that we are putting together here to get ready for the end of AP Statistics and get you guys ready for the AP test. Now, I'm making these videos from my home, April 2020, and to my current students, I hope you guys are all doing well. Let me know, as always, if there's anything I can do to make things easier as you're learning remotely. But I do plan to use these videos more in the future as well. So to my future students, if this is 2021 or 2022 right now, here I am talking to you from the past. This is so crazy. But we're going to learn about a little bit of statistics back in Chapter 4 with our sampling and our experimental design. So your instructions were to read page 276 of your book, which is a one-page summary of everything in the chapter. If you understand that page, you're in really good shape, and it'll jog your memory on a lot of stuff that I taught you way back in August. After doing so, there are also 3 pages in your book that I have written right here. They break down the section one at a time, so you can get all the key vocab words. Most of the things I made you define here are all just vocab words on those pages that you can get. But read through that in your book and then fill out this first page on your own. I'm not going to go over any of this stuff in the video right now. What I am going to do is go over the multiple choice questions and then the first of the free response questions that I put at the end of this packet. Now, for my kids in 2020, this year there is no multiple choice on the AP test. It's just 2 free response questions, like I told you via email. But even though that's true, I still am going to have you guys do bits of multiple choice here and there because it allows us to review a lot of different topics and a lot of different vocab concepts really quickly. So we're going to kind of jump in with these, and they should jog your memory on things you saw way back beginning of the year. So anyway, number 1 is giving you a random number table, which we've dealt with before. And what you're going to do with this is take your digits, they're numbered 1 through 50. You want to take the digits 2 at a time. So my first 2 digits, for example, are 1 or 11. That'd be the first person out of the group that I picked. They all start with an 11, nothing too crazy right there. Next 2 digits go 36, so I should have that, and then a 23. But after the 23, we get a 56. We're going to reject that 56 because my numbers only go up to 50. Similarly, I have to reject 92. I have to reject 96. And I actually already picked 23 right there, so that gets rejected as well. 79 also rejected. Number tables can be a little tedious. That's why we like to use our calculators. But the next good number would be 08, and then that is finished with a 42, making B the best answer for this question. So our answer for our first multiple choice question should be B. All right, moving on to our second question. That's kind of interesting. I wonder if you guys can see this floating off the screen here. Oh, well. On to our second question here. We're looking at a big forest of maple trees, and we want to take an SRS and look at the diameter of these tree trunks. So when we're doing this, really hard to do an SRS in this setting because there's just way too many trees running all over the park to different sections to track them down. It's just too much. So instead, what he's going to do is he's going to break his trees up into little 10 by 10 chunks. So that's like one little zone of trees, that's another zone, etc. And then once he has all these zones in place, what he's going to do is number off his zones, so 1, 2, 3, all the way up to however many there are, and he's going to pick 25 of these different plots. So he might pick number 2, and he's going to all the trees within this plot. This is an example of a cluster sample. Each group is exactly, or theoretically, the same. And once he makes his random selection, he goes to everything within those groups. All those trees he would go and measure. Cluster samples are often easier to do when you have big groups in nature or in like public or something like that, where you couldn't kind of run all over the place as easily. So this is definitely a cluster sample for number 2. Third question is looking at headaches here. And we have 25 people who had headaches, and we decided we're just going to give all 25 of these people a new magical remedy, some sort of medicine or something like that. And then we check in with all 25 of those people. 4 hours later, we find out that 20 of them say their headaches are gone. So this is a very poorly designed experiment, and the reason for that is it's not an experiment at all. They did not have any sort of a comparison. They use the word control group. The correct answer on this question is C. Kids get caught up on the buzzword control group a lot, though. The important thing is that there's no second group for comparison. If you give everybody the medicine and wait 4 hours, your headache is quite possibly going to go away just on its own. What we have then is the concept of confounding. We don't know if the headache went away because of the medicine or because of the fact that time passed and headache went away on its own. So what we would have to do is have two groups randomly assigned where maybe one group got medicine and one group just waited. And then we would look to see if the rate of headache going away was higher in our medicine group. And that would tell us that, oh yeah, the medicine probably did make a difference because both groups would have experienced that 4 hours of wait. Then the only difference between them theoretically is the fact that one group got medicine. All right. Fourth problem here. This is a scope of inference question where they're basically asking, where can I apply my results? What can I actually say about what happened right here? So they had 80 volunteers who take a certain kind of medicine already. They're already taking medicine. And what they're going to do out of those 80 people is they're going to give 40 people the new medicine randomly assigned, and they're going to give 40 people, just tell them to keep using their same medicine. And they're going to look at 2 weeks to see how the allergy symptoms compare. So this is random assignments. So we do, in fact, have random assignment in this problem. We broke them up into a group that got a new medicine, kept their same medicine. But this is not random sampling. The people in my study were volunteers. They were not randomly sampled. If you do not have random sampling, you cannot talk about the population. We cannot say anything about like people overall and how this new medicine works. What we can do is we can talk about these specific people, or you'll see a lot of times they'll do like a little qualifier, people like those in the study, and that's what they'll say instead. So we can only talk about these people or people like them, but we did have random assignments. Random assignment allows us to determine cause and effects. So we can determine that the new drug, or whether the new drug, reduces symptoms more than the old drug. We can say that the new drug is actually better and that the difference we're seeing is because of the new drug, but we can't say it applies to everybody, only to those in the study. All right, number 5 is a vocabulary question. And I didn't make you guys define all these little words like treatment in the first page because I think they're fairly easy to remember and I didn't want to make it too long with our vocab list. But this is an important question that is easy to get tripped up on, so please be careful as we go through this here. We're taking these like little fruit packs and we're measuring the amount of vitamin C in the fruit packs at 6 months later, 12 months later, and 18 months later. So we're going to store, let's see. Yeah, they're checking to see how long they store them for. So the treatment in this study is the first thing they talk about. Treatment is what you actually impose or what you do to your different groups in an experiment as the researcher. And you are choosing a storage time. 6 months, 12 months, 18 months are your 3 treatment levels in the problem. So C is wrong, B is wrong as well. Experimental unit is a big one here, and this is something I actually want to talk about. On the 2019, so this is last year's test for my current students. Oh, you're all my current students, I guess. For my 2020 kids, on the 2019 AP test, one of the free response questions was talking about like this fungus that they were going to use to try to kill insects. And they put a bunch of insects like in little jars. Oh, I've got a semi-jar right here. So they put a bunch of insects in a jar and they had a bunch of these jars laying around. And what they would do is put different concentrations of fungicide in the jars. And what the problem said is it asked what the experimental units were. Okay, so this was the exact thing that they're asking you for in this like vitamin C question. Lots of kids on the AP test last year got this question wrong because they said that the experimental units were the insects within the jar. So the insects are your units. But the experimental unit is the smallest like thing that you are imposing treatment on. the things that are getting the different treatments. And the bugs themselves are just sitting inside this jar right here. Each jar was actually considered the experimental unit because you're putting a different amount of medicine or whatever in each jar. Okay? A lot of kids said like the little insects within. Similarly, on this example here, getting back to our current problem, the experimental units are what are actually getting the treatments, and I'm taking a pack and I'm putting it for 6 months, 12 months, or 18 months. So the fruit packs themselves are the experimental units, not 6 fruit packs, okay? Each fruit pack gets its own treatments. And finally, the response variable, you're just measuring the amount of vitamin C. So this problem answer is D. On to our final multiple choice question. And if you look at this problem right here, you're trying to decide trying to remember what this problem is about here, 3 versions of a commercial, and they think that it may appeal differently to people who are employed, women who are employed outside the home and women who are not. So if I took all my people in this study and I just divvied them up right away, randomly, so I have 3 groups. I could unfortunately have it where just, more people who work at home are in this one group just randomly. And what that would do is it's not biased because I still randomly assign, but it would increase the variability of my data set. So I would have more variability in what could happen for my data, makes it harder to see what's going on. So what they would do instead to kind of mitigate that, if they really do believe that staying at home makes a difference here, this handwriting is all with my little trackpad mouse, so sorry it always looks kind of messy here. You have your stay-at-home women, and you have, that's not what it is. It's like employed outside the home. Okay, so outside home for my other group, whatever. I got my 2 groups right here. And what I would do is take all of these women and randomly break them up into the 3 treatments. I would randomly assign each of them to 3 different effectivenesses on commercials. I would do the same thing right here. That way, I would have some stay-at-home women in each group, some outside the home women in each group, and then I would be able to compare within just that category. That concept is called blocking. When you're doing an experiment and randomly assigning, you're doing a block design. If I was taking the same concept, but I was doing a sample where I pull in data, so I take some from this group, some from this group, that's called stratified sampling. So stratified sampling is when you take the data in. Blocking is when you start with the group that you already have and you break it up into separate groups. They're kind of reverses of each other. All right, and let's get on with our free response question right here. This is a fairly frequent free response question. It's a really good one for practicing this chapter. I believe it was on the 2016 test. I think I've used this question. I use this question a lot in class. It was on the semester exam one year. So I know a lot about this question and what my specific kids do wrong. So make sure you listen to this because hopefully it'll be somewhat good insight here. So the first thing that's going on is you've read the problem already, but we're looking to see if smoking makes a difference on your risk of developing Alzheimer's later on. So the explanatory variable in this problem is going to be whether or not you smoke. Okay. Now, when I actually write that out, I'm going to write down smoking status for my actual variable here. So I'm going to go black, but I'll highlight it. That'll look real good. So smoking status, or you could say whether or not you smoke. Something like that. What kids will do very frequently, and what I'm guessing some of you might have done because I've seen it happen, they'll just say smoking for the explanatory variable. But that by itself was not good enough to get full credit on this question because you have to show in some sort of way, what is it about smoking? Well, it's whether you do or you don't. Do or don't smoke. Or you could say smoking status, something beyond the word just smoking. Okay. Similarly, on the response variable, you need to say something like people would just say smoking, Alzheimer's, done. That would not have gotten full credit on this question. So for this one, what I would want to say is something to the effect of whether or not you develop or the subject developed Alzheimer's. And that would be a good full credit answer for that first problem. All right, on to part B. B is a really important question and a very easy one to answer. They're asking whether something is an observational study or an experiment. Your keywords that you're going to want to use to do this problem is treatment imposed. Was treatment imposed on the subjects in this study? The answer is no, because it would have been unethical to tell people you're going to smoke, you're not going to smoke. So this is an observational study. Treatment was not imposed. They were not told whether or not to smoke. They were just left to their own devices, and after the fact, experimenters collected data. So in order to get full credit on this problem, this is an observational study because treatment was not imposed on subjects. Okay, so treatment was not imposed or treatment was imposed. Those are the key words you're going to use for this problem. But my answer right now does not have context, so I'm going to give a follow-up sentence. Experimenters did not assign subjects to smoke or not smoke. They simply collected data on Alzheimer's and checked smoking status. I'm writing this off the cuff, so it's not like a perfectly worded answer. You certainly could have said something different here. For this problem, you need two things, though. It's an observational study because treatment is not imposed, and some sort of context explaining your answer further. All right, that takes us to our last part of this video. I am not going to go over the second question together, but what I will do is after you submit your answer, and like I grade them and everything, I will leave you comments if you did not get full credit. So on this last question, make sure you guys look at it, use your notes to help you, but give me good, thorough answers. This will be good practice for the AP test on that last one. But on my last question here, they mentioned that exercise status could be considered a potential confounding variable. And this is a problem that when I've used this on our semester exam, kids rarely get full credit on it because they forget part of the answer. There are two things you have to do for this problem. First of all, recall that confounding means we've got these two things going on, and I've done this thing with my hands in class. You've seen me do this before, but they're so intertwined that we can't tell which one is actually responsible for the effect that we are seeing, okay? So we already got this smoking going on right here. Smoking is one potential factor or variable for why Alzheimer's risks may increase. They're suggesting that this exercise over here could actually be responsible instead and be a confounding factor. You have to do two things to get full credit on this problem. First thing you have to do is explain how exercise status could be related to smoking. Okay, so if you are already smoking, stereotypically, you probably are not as concerned with your health overall. You're making a bad health decision. So if you're smoking, you're already making a bad choice. That probably means you're less likely to exercise overall. So a good full credit answer, the first part I'm going to say for this, people who smoke are probably more likely to, or less likely, I guess I should say, might sound better. So they're probably less likely to be conscious of their health or to make good health decisions or something like that. As a result, they may be less likely to exercise since they are taking other health risks. Again, writing this off the cuff, so that gets the idea across that basically people who smoke are probably less likely to exercise. You have to make that connection first, okay? Now, to get full credit in this problem, you have to do one other thing. The second thing, for it to be a confounding factor, it would have to be where, oh, I thought it was going to be smoking that was responsible, but ooh, it's actually exercise. So I showed how smoking is connected with exercise, but I have to follow that up with saying how exercise could actually be what I'm seeing, why the Alzheimer's rates are higher. People who exercise less may be at higher risk of Alzheimer's due to the lack of physical activity. Evidently, I can't spell Alzheimer's. So, looking at this problem here, again, two things you need to get full credit. Smoking relates to exercise or lack thereof. Exercise actually could lead to higher rates of Alzheimer's. So make sure you do that last question and let me know if you have any questions. Otherwise, that's the end of our first video.